Hello everyone. Welcome to the solution of LeetCode problem 337 named House Robber 3. In this problem, the problem statement is very simple. We are given a binary tree and we know that in the binary tree, each root has two children, which is left children and right children. Suppose you are a thief and you want to rob the element stored in this binary tree. In each node of this binary tree has some amount of money. Suppose the first node or the root node have the amount of money 3. The left tree or the left children of this has the amount of money 2 and the right one has amount of money 3 also. Here the condition is if a thief steal money from a node, it cannot steal any other money to the adjacent node. That means if someone steals money from this first node, he or she cannot steal the money of this node and this node because these are adjacent. If they do so, it will automatically call the police. So here we have to find the maximum amount of money that thief can rob without alerting the police. Suppose in the first example, the thief steal the amount of money 3 presented in the first node and skip these 2 and these 3 node and again still in these 3 and this 1 node. So the total is 3 plus 3 plus 1, which is 7. So here, according to the condition, the thief can steal the total amount of money, which is 7. Now in the third node, but now in the second example, the root node has the value 3. The children has the value 4 and 5. And 4 also have two children where the value is 1 and 3. And 5 also has a children which value is 1. Now, here, one of the condition is either a thief can steal the money 3 and cannot steal the money 4 and 5. And again can steal the money of 1, 3 and 1. If he do so, then total amount of money is 1 plus 3, 4, 4 plus 1, 5, and 5 plus 3, which is 8. Another possible solution is a thief can skip the first root and steal the money of 4 and 5. So here, the total summation is 9, which is obviously greater than the previous solution 8. So in this case, the optimal answer is 9. I hope you understood the problem and the example. Now the constraint are, the number of nodes in the tree can be in between 1 to 10 to the power 4, and each value presented in the node can be in between 0 to 10 to the power 4. I hope you understood the constraint. Now let's move on to the solution. Here, the solution is pretty simple. To solve this problem, we are using the depth first search algorithm. And let's consider the second example. Here, the root node is 3. The left subtree or the value of the left children is 4 and the value of the right children is 5. Here, the value of the left children is 1 and the value of the right children is 3. And for root 5, the value of the right children is 1. This is the basic explanation of this input tree. Now, the optimal algorithm is, for each node, I have two conditions, whether I can take it or I cannot take it. This is the two conditions. Suppose, let's understand the theory by using this small tree. Here, suppose if I take the first node, which is this, then I cannot take the immediately children of it because they are adjacent. And again, I can take the next level of the node. This is one possible solution. Again, one of the solution is I cannot take the first node and I take this nodes and I cannot take the next level of nodes. This is one kind of solution. So for a root, I have two choices. Either I can take it or I can ignore it. If I take it, I cannot take the immediate children of it, or if I cannot take it, then I can take the immediate children of it. Now, in the DFS call, each node will return two values, where each value contains two elements. At first, which is the root, and secondly, it will return the maximum number of amount the thief can steal from this root, which is amount. Basically, this is the theoretical part, and understanding this theoretical part will be a little bit of confusing right now, but it will be clear after I explain this entire given tree. Now let's erase it. Now in the DFS call, at first we are in the first node, and from the first node we will go to the left children and right children. Now from the left children we will go to the left children again, and we will go to the right children. Now from this left children 1, which is the leaf node, it has also two children, but the value of them is null. So for this subtree, if someone broke into this subtree, the thief can gain the value of 1. So here the return value will be 1 and 1. The first one is the root element 1, and the second one is the amount of money if someone try to steal in this subtree. Now we are at node 4, and the call is in the node 3. Here node 3 also has two children, both of them are null. So from node 3, it will return the value of 3 and 3, because if someone steals in this subtree, he can take only the amount of 3. So here 3 will be returned. Now we are in root 4. So for root 4, we have two conditions. Either I can take root 4 or I can ignore root 4. So if I take root 4, I cannot take the value of return from 1 and 3. So here, if I take root 4, then the value will be 4. And similarly, for the next condition, if I cannot take the root 4, the value will be returned from 1 and 3. So here the value will be 1 plus 3. So here for root 4, the value will be maximum of 4 and 4, which is 4. So root 4 will return the value of 4. Anyways, this 4 and 4 is stored in the map, where the first 4 is the key and the second 4 is the value. Now we are in the node 3, and from node 3, the call will be in the node 5, and from node 5, the call will be in the node 1. So again, node 1 does not have any other children. So if someone broke into this subtree, he will only take the value of 1. So here the 1 will be returned in a key value pair order. Now for node 5, I have two conditions. Either I can take it or I can ignore it. If I take node 5, then I cannot take the immediate children value, which is 1. So here, if I take node 5, the value will be 5. And if I ignore node 5, the value will be 1, which is returned from its children. So here, the node 5 will return the value of maximum of 5 and 1, which is 5. So this 5 is the node number 5, and this 5 is the value returned from it. Now I have two values, which is 4 and 5, that is written from the left and right subtree of node 3. Now for node 3, I have also two choices. Either I can take it. If I take node 3, the summation will be 3 plus the value 1, 3 and 1, which is 3 plus 1 plus 3 plus 1, which is 8. If I take node 3, because if I take node 3, I can take the value this level and this level, and I cannot take the value from this level. Now, if I take node 3, I can acquire the 8 amount of money. Again, if I cannot take node 3, I can take the value written from its immediate children, which is 4 and 5. And their summation will be 4 plus 5, which is 9. Now, the optimal strategy for node 3 will be maximum of 8 and 9. So here, node 3 will return the value of 9, which is the maximum of 8 and 9. So for this problem, the answer will be 9. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named rob. The input parameter of this function is a root of a binary tree. Now inside this function, I am declaring a map. The key of this map is the root of a binary tree, and the value is an integer. The value will contain the maximum amount of money I can rob in the subtree presented in this root. Now we have to call a function where the first parameter of this function is this map, and the second parameter of this function is the given tree, which is root, which is this. Now at first, we have to check whether our current root is null or not. If it is, then we have to return 0. That means we cannot rob anything. Otherwise, I have two choices for a root. I can simply take it or I can simply ignore it. Now, for the simplicity of calculation, I have first stored the value of root into a variable answer. Now, here I have to check whether I have completed the iteration of this node before or not. If I did it before, then we can simply return the value presented in the map. Otherwise, I did not iterate this node before. That means I have two choices. Either I can take it or I can ignore it. If I take the current node or the current root, then I have to check whether this root have the left children or not. If this root have the left children, then we have to accumulate the value of the left node's left children and the left node right children, their summation to the answer. And again, if our current root has the right children, so we have to accumulate the value of right children's left node and the right children's right node to the answer. So here, answer contains the value, which is the summation if I take the current node. Now we have to return the maximum of, we have another choice. Either I can simply ignore the current node. For this, we can simply call this recursive function into the left subtree and into the right subtree and make the summation together and put the maximum of them into a map. Finally, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. Now for the time complexity, as we are using the depth first search algorithm and we are visiting each node exactly 1 times. So the time complexity is big O of n. And for the space complexity, as we are visiting each node exactly 1 times, so the function call stack in the worst case will contain all the value. So here, the size of this call stack can be equal to the size of the total number of nodes presented in the binary tree. So we can say that in the worst case, the space complexity also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.